closed and open circuit. If you see both the wires are connected to both the terminal, it is an unbroken path. It is a closed circuit. Disconnect one of the wires. You'll find that the path is broken now. Also, the bulb doesn't light up since electricity can't flow through this circuit. A broken path is known as an open circuit.
Let's experiment a little bit with circuits. As we discussed, electricity will only flow on a closed circuit such as the one shown on the screen. Notice that the electrons flow through the wire and each of the bulbs before they return to the battery. If one of the wires breaks, a gap occurs in the circuit and all the lights go out. When lights are lined up one after the other on a circuit like these lights are, it is called a series circuit. The problem with a series circuit is that when one light burns out and its filament breaks, it creates a gap in the circuit. All the lights go out because electricity won't be able to flow to the other bulbs. This problem can be solved with a parallel circuit. In a parallel circuit, the wires that are connected to light bulbs run parallel to each other rather than having all the bulbs in a row. This means that one light can burn out or be removed, and the other lights on the circuit will stay lighted. For example, if we remove the light that is closest to the battery, the other two lights don't go out because each light is connected in a way that the electrons have a complete path to travel to the positive side of the D-cell battery. Now let's practice what we've discussed about circuits with an activity.
Even if you don't totally understand what electricity is, you are probably very familiar with it and use it throughout your day. When you turn on lights in your room when you wake up in the morning, when you use your electric toothbrush to brush your teeth, when you use your toaster to toast your bagels for breakfast, and of course, you used it when you turned on your computer and brought up this video. Exactly what electricity is can be kind of an abstract concept, but for now I want you to think of it as tiny particles that we call electrons. But how do these electrons make all of these different appliances work? It turns out that on their own, the electrons don't do much. But when they move, their movement generates energy, and that can power all of these different things. To talk about how this works, we are going to use a really simple example that I have drawn out here. And this is a very simple version of a flashlight or a torch. So here we have a light, and this light is attached by two wires to a battery. And when all of these things are connected in a loop, we say that we have an electric circuit. In this case, a very simple one. Electrons can flow through this loop, which we call an electric current. And as this happens, it can turn up lights, move motors, and heat things up. But no matter what job it's doing, we can always think of a circuit as a path through which electricity flows. There are a few things that I want to point out about this circuit. First, I want us to look at the battery. And the battery provides the power that causes the electricity to move around the circuit. And this battery, in fact all batteries, have a positive end and a negative end. And electrons are pushed out from the negative end and move towards the positive end. And the wires provide the path that the electrons can move through. Another thing you need to know about this circuit is that it only works if it is closed. If there is a break anywhere in the circuit, like if a wire was broken or not connected to the battery, the circuit wouldn't be complete and the light would no longer light up. And we could make this circuit a little bit more complicated by adding things like other lights, but we could also add things like switches. Switches are components that purposefully break the circuit, but then they allow you to open and close it as needed. So think about a light switch. When the switch is down, the circuit is broken and the light is off. But when you turn the switch on, it completes the circuit, it closes it, and this allows the light to turn on.